Hello and welcome to the video, and today we're going to be talking about FEM analysis, deconstructive testing, and forces that are applied to prints. Today we are going to explain why print orientation matters, how orientation can be used to improve strength, and why certain parts are actually better designed as components instead of one single piece. When someone looks at a model on a computer, it is easy to focus only on the external shape. Does it fit the available space? Are the holes in the correct spot? Does it resemble the original part? Those questions are very important, but they are only the beginning. A part can fit perfectly and still be unsuitable for its application. In the background, I have a hook that I normally use. It's 3D printed in PETG CF normally, and it has over 25 pounds loaded on it at all times. In the background, I have it shown that different infills and the time that it requires. So adding more infill is not always the solution. If you're advanced on 3D printing, you know that increasing walls is often better than increasing infill. Not only do you need to focus on the walls and the infill, you need to make sure that the print is printed in the orientation that best suits it for the forces and load on the part. If this hook was printed in this orientation in the background, it would break and it wouldn't work very well. So it needs to be turned on its side to give the full strength and value from it. If I had to guess where it would break, it would probably break right there, right where I shown. With FDM printing, the part is created one layer at a time. The printer lays down individual paths of melted material. Those paths form one layer, and each new layer bonds the material beneath it. Because of this process, the finished part does not necessarily have equal strengths in every direction. This property is called anisopatry. These are all the different forces that can act on a part that you make. Today, we're going to be focusing on tension, because that's the part that will try to separate the brackets that we made. I'll be upgrading my test bench setup later so that we can measure maximum forces with a proper tensiometer, and we can also add more weights. I also plan to go into more detailed videos on these different tests and to continue our deconstructive testing. If you have any ideas that you'd like, drop a comment down below. Here in the near future, we're going to test different ways to connect parts, such as glue joints, plastic welding, and other ideas. This is a little infographic that I made to help you visualize and understand how interlayer separation happens. If you find things like this helpful, please let me know. But let's move on to the deconstructive testing. Let's rewind that and slow that down real quick. This is the best way to print this part. And it's not just for strength, but also for looks. To have these holes accurate, you need it to be flat. And also you can see here how the layers are stacked up and how the load is separated in that hole. Versus this, the vertical design, which the holes will be drooping and you can see exactly where they will separate as the video just showed. As you can see here on the horizontal part, the holes are very round and accurate. While here, you can see the layer line issues because of the vertical printing and the holes are not as good looking. Let's talk about FEM and more importantly, what it is. Finite element analysis, or FEA. It is a computer simulation that divides a design into thousands of small sections and predicts how they will bend, stretch, or fail under force. It helps us understand weak points and what to make stronger. Today, we're going to be using FreeCAD's FEM workbench, which I honestly absolutely love. With the FEM, we can predict where the most stress will be. As you can see here, if you look around the holes, that's where most of it is. And this is with the Matt's principal stress, which is good for tension. This is the displacement. And as you can see here, the most amount of stretch is going to be right where the top of the hole is. If you would like a video on doing an FEM in FreeCAD, please comment down below and let me know. This is a 3D corner bracket that I downloaded from Phoenix Art Labs. And we're going to talk about it here and how to make something that has no true good spot to print better and easier and stronger. If you were to have this part, it would probably break right here and you'd be left with these two pieces. But what can we do to fix it? First of all, we can go ahead and move down and go to cut it, right where the layer line is. That way we can print the other part in the strongest orientation while still having good screw dimensionality. However, the question is, how do you mount it? You don't want to use a butt joint because those are weak. So instead, you can enable the dowels or plugged or whatever method of connection in Bamboo Studio or Orca Slicer. And you can place those, change the depth ratio, and you can put it together with glue, and it'll be a lot stronger than the original part. As you can see here, I'm changing the depth ratio, trying to put everything in the center. I went with the dowel option, which is my preferred method. You can also use the snaps, the plugs, and you may have to mess with the tolerances a little bit. But this tool is very easy to use in Bamboo Studio. So we can perform the cut, and then we can align the parts and reprint it in the best orientation. In the future, I'll be using this very same design and showing off these joints, but not today. As always, if you have broken, discontinued, or poorly designed components, Cast Design Co. can help develop a custom solution. Visit our website at www.castdesignco.com and tell us about your project. Subscribe to follow more scanning, prototyping, testing, and manufacturing projects. I have lots in the books for us. If you have any ideas, please comment.